everyone, my name is Liza Milianto and I'm here to discuss to you the bubble sort. So first things first, what is bubble sort?
So bubble sort is a sorting algorithm that compares the two adjacent elements and swap them until they are intended orders. So this algorithm, which is the bubble sort, is not suitable for large data sets, as it is the average and the worst case complexity are O of n raised to the power of 2, where n is the number of the items. So here, this is how the bubble sort works. So we have an elements 14, 33, 27, 35, and 10. So all we need to do this is to sort them. So the first iteration, it will compare the two adjacent elements, which is 14 and 33. If the first element, which is 14, is less than 33, it will not swap or change their position. And the second iteration, it will compare the two adjacent elements, which is 33 and 27. If this here, if 33 is less than 27, then it will not change their first position. However, 33 is greater than 27, which means that they're going to swap. So 27 will be the second and 33 will be the third. So we find 27 is smaller than 33 and these two values must be swapped. So now we have a new array. So 14, 27, 33, 35, 10. So as we have noticed, it's not yet sorted. So we need to iterate this, or we need to sort them. We still need to compare the two adjacent elements. So 33 and 35. Since 33 is smaller than 35, so it will stay at their position. So next is the two values, or the two adjacent elements, which is 35 and 10. Since 35 is greater than 10, then these two must be swapped. So the new array is 14, 27, 33, 10, and 35. Now, to be precise, we are now showing how an array should look like after each iteration. After the second iteration, it should look like this. So same process, it will compare the two adjacent elements until it will find the smallest element. All the smallest element will be at first, while the largest element will be in the end. So why bubble sort is called bubble sort? The bubble sort sinks the heaviest element to the bottom, causing the lighter elements to bubble up.
So here I already created a program that implements the bubble sort. So in this program we will be sorting elements in ascending order. So we will bubble up the lightest or the smallest number in our array and shrink the heaviest element in our array. So here in this line, we will just print the array before sorted. So we will just print this. So to print this, we have a method. So we're calling a print array. This is a method which will be printing all the elements that are stored in our declared array. So we will just proceed here. We'll see the method, and this will iterate from 0 to the 10. No, 9. By the way. So this will only print the arrays that are stored in our array. So here we are calling our method. This method executes, or these methods will sort our array from here, from index 0 to index 9. So our given elements, we will sort this by using this method. Since this is called this sort method is being called, so this here will execute. So inside of our method, we declared an integer n with a value, and we initialize it to array.length, which is our numbers of our array, which is 10. So the value of our n variable is 10. So this is not really necessary that you're going to do this. You can just put array that length here. It still works the same. Minus it works the same. Nothing's different. But for now we will just use the n since we're using it, since we declared it. If we're not gonna use this, this will become useless. So in this here, as we have noticed, we have two nested for loops, which means nested for loops means there's a for loop that has a for loop inside of it. So this for loop, the outer for loop, iterates over the array from the first element to the second last element. The variable I represents the current iteration of the index, while the inner for loop iterates over the remaining unsorted portion of the array. Comparing the two adjacent elements, the variable j represents the index of the current element being compared. So let's just assume that this is true since since I is 0, so this condition is true. Then it will proceed here, and again, inner loop iterates the remaining unsorted portion of the array, comparing the two adjacent elements. When you say adjacent elements in Bisaya, it's tupad. So example ani is 12 and 94. So this 2 is adjacent element. So now let's just iterate. I'm gonna show you how these bubble sort ascending works. So let's just assume that this is true. So then we will proceed here. So we have j is equals to 0. 0 is less than 10 minus 0 minus 1, which is 9. And this is true. So just put here true. So now, since the condition here is true, then we will proceed here. So our array index 0, since our j is 0, current index is 0, is 12, is being compared to 94. So this condition becomes false, since 12 is less than 94, but the condition is 12 is greater than 94, which is false, so there's no swapping happen. So this will proceed here. J becomes 1 since we implemented it. So the condition came up true, and then we will proceed here in our condition. So our current index j is index 1, which is 94, is being compared to the next element, which is 86. And this condition is true, since 94 is greater than 86. So how 94 is swapped by 86. So 94 is being temporarily stored in temp variable. So the 94 will be temporarily stored in our temp variable, and then our 86, the 86th element will be stored in array index 1. 86 value, sorry. So now our current placement of our array is 12, 86, 94, negative 47, 61, negative 35, 73, 29, 0, negative 11. So here, our 94 is now in the index 2. Which is 94. So next iteration, so j becomes, so j is just say j 1 plus 1 becomes 2, so our will be in the index 2. So this is still true, and then we will proceed here. So our current index here is 2, which is 0, 1, 2, which is 94, is being compared to array, to its next array, which is negative 47. And this will become true again, since 94 is greater than negative 47. So again, since this is true, the 94 will be temporarily stored in temp, and our index 2 will be negative 47, since negative 47 is in the 0, 1, 2, 0, 1, 2, 3. Since our negative 47 is in the index 3, and now our array index j is equal to array index j plus 1, which is negative 47. Our negative 47 is now in the index array 2, and our array index 3 is 94. So next iteration, so j becomes j, j becomes 3. So 3, so our condition here is still true. So now let's proceed here. So 90, our current index is 94. Our current index is 3, and it has a value of 94. And 94, wait, and 94 is being compared to the next, or to its next element, which is 61. And this is still true. So 90 is stored in temp variable, and our array index 3 is now 61. And then our index 4 is 94. So now our index 4 is 94. Let's iterate this, or let's go back to our for loops again. J becomes 4 now. So 94, our index 4 is 94, and 94 is being compared to 35, negative 35. And this is true, since 94 is greater than negative 35. And again, 94 will be temporarily stored in temp, and our array index 4 has a value of negative 35 now, and our index 5 is 94. This process continues until this here condition becomes false. If this iteration becomes false, then the next iterations will be here and the I will be incremented into 1 and I will be added to 1. So 0 plus 1 plus 1, this becomes true. Then can proceed here and perform this inner for loop, and this inner for loop will execute until this condition becomes false. So same process rin sila until these elements become sorted. So let's just erase this and I'm gonna show you the result or the output of this code. Let me just so after iterating after performing this method, it will go back to the main method and it will display sorted array in ascending order, and again it will print the array in sorted array. Since we already sorted these arrays here, these elements rather, that are stored in our array variable, then this will print a sorted elements. So this, I'm going to show you the result. So as you can see, 1294, like what I've said earlier, it will only print the unsorted elements, and then the next thing is it will print the elements in a sorted array. So why is it bubble sort is it suitable for large sorting or large data set? So we need to keep in mind that bubble sort has a time complexity of 2 of n raised to the power of 2, where n is the number of elements in the data set. This means that the time it takes to sort the data set using bubble sort grows exponentially with the size of the data set. For example, if you double the size of your data, the time it takes to sort it will quadruplet. That's why bubble sort is not recommendable for sorting large data set. It will only recommendable for sorting small data sets like 10, 5, or less than 20 data. Because the more you sort a large data, it will take too long to sort it, since these algorithms compares the two adjacent elements. So yeah, that's it for today. I hope you understand my discussion about bubble sort. So bubble sort is so simple, yet it's not recommendable for sorting data. So I hope you learned something, and yeah, goodbye.